So starting with the redox unit, we're going to look at first some redox vocabulary and a couple of key terms that are really needed in order to understand the rest of the unit. In my opinion, these are the main terms that you need to know in order to understand what's going on with all the rest of the content, because we're going to refer back to these terms basically in every other concept that we cover. So the first one is a term called reduction, and you can see the definitions here really quickly. Reduction is when a substance gains electrons. In a redox reaction, you can see the name shows that we have a reduction and also an oxidation. And so an oxidation is when a substance loses electrons. And in a chemical reaction that's a redox reaction, the substance that's gaining electrons is going to be making the other substance lose electrons. In other words, we just have an electron transfer from one substance to another. And so there's two other terms that we use for associating those substances with each other. And so we have what's called an oxidizing agent, and this is a substance that causes another substance in a reaction to be oxidized. It's doing the oxidizing on that substance. A reducing agent is just the opposite. It's a substance that causes a different substance in that reaction to be reduced. In other words, it's doing the reducing on that substance. So you take a look at this example over here. We've got two half reactions. This one right here is written as a reduction half reaction. So I've got it lined up here with the terms so you can see what's associated with what. This is a reduction half reaction because we can see the electrons are written on the reactant side of the equation, signifying that this copper 2 positive is going to be gaining these 2 electrons, turning into copper solid. This half reaction shows an oxidation half reaction where a substance is going to lose electrons. And so how we show that in a chemical equation form is we write the electrons on the product side. So this is much like the energy unit that we talked about before, where if we have a reaction that's endothermic, gaining heat or absorbing heat from the surroundings, we write that energy term on the reactant side. So it is with reduction half reactions. When we have a substance that's gaining electrons, those electrons are going to go on the reactant side of the equation. For an exothermic reaction, when we write energy terms in those reactions, we write them on the product side, showing that that reaction is losing heat. And so it is for substances that lose electrons. We write those electrons on the product side to show that that substance has lost those electrons. And so a redox reaction, redox, is a reduction half reaction combined with an oxidation half reaction. So every redox reaction is made of two halves. One half is a reduction and the other half is an oxidation. So you'll hear the term reduction half reaction and oxidation half reaction quite a bit. This one is the reduction half reaction. And this one is the oxidation half reaction. So what I can do with these two half reactions is I can combine them together to make one full reaction. Two halves make a whole. And the way that I do that is I want to make sure that I balance the electrons on either side of the half reaction. If I'm gaining 2 electrons, then I must lose 2 electrons. And that means that if I'm going to multiply the number of electrons in that half reaction by 2, I have to multiply everything by 2. And so that's going to be a 2, and then I'm going to stick a coefficient of 2 in front of all the rest of those. Once the electrons are balanced, then I can write that out as a full redox reaction, cancel out the electrons. And this is my redox reaction. Sometimes redox reactions are referred to as net ionic equations, or net ionic reactions, however you want to say it is fine. And in this reaction, we know that, because this is the reduction half reaction, that the copper 2 positive is being reduced and the Ag solid is being oxidized. Now, the copper 2 positive, because it's being reduced and gaining electrons, it is the thing that is causing the silver to be oxidized, which makes the copper 2 positive the oxidizing agent. And because the silver is being oxidized, it is the thing or the substance that's causing the copper 2 positive to be reduced. So that makes the silver solid the reducing agent. And the oxidizing agent and the reducing agent, the things that are being oxidized and reduced, those are always found on the reactant side of the equation.